question that's going to bother you for the next few minutes. What would happen if you took a normal fish, removed its tail, replaced its skeleton with rubber, fused its teeth into a single beak, gave it a brain smaller than a walnut, and then dropped it into the middle of the open ocean with no defense, no speed, and no real way to survive? You'd get the ocean sunfish. And somehow, it's one of the most successful creatures in the sea. This animal breaks nearly every rule that evolution has spent 500 million years writing. And yet, here it is, thriving, everywhere, completely unbothered. While species with actual advantages are going extinct around it, the sunfish just keeps existing, like it didn't get the memo that it should have died out long ago. So what is actually going on here? Because this isn't just a weird-looking fish. This is an animal that found a completely different answer to survival, one that no other creature on the planet figured out. And once you understand what the sunfish is actually doing, you're never going to look at it the same way again. Let's start with what's wrong with it, because the list is long. A normal fish is built around one central idea: movement. The tail generates thrust. The scales reduce drag. The streamlined body cuts through water like a blade. Everything points forward. Everything is designed around the ability to chase or escape. The sunfish threw all of that away. The tail is gone. Not reduced, not small, gone. Where the tail should be, the body just stops, replaced by a frilled, rubbery flap called a clavus that functions more like a steering wheel than an engine. It provides zero forward thrust. It just helps the fish turn. The skeleton, which in most fish is a rigid, supportive framework, has been largely dissolved and replaced with cartilaginous tissue. Lighter, softer, more flexible. On paper, this sounds like a bad trade. In practice, it makes the sunfish nearly impossible to kill. But we'll get to that. The scales are gone too. Instead of the sleek, protective armor that covers most fish, the sunfish is wrapped in a skin that's essentially thick, wet leather, up to 3 inches of dense, rubbery hide. If you pressed your hand against one, it'd feel like touching a sanding block that somehow got soaking wet. No real ribs, a spine so short it's almost vestigial, teeth that have fused together into a single beak that permanently locks its mouth half open, giving it the permanent expression of an animal that just heard some surprising news and hasn't recovered yet. Every single one of these features should be a fatal flaw, and yet every single one of them is actually a solution. You just have to know what problem it's solving. For decades, scientists wrote the sunfish off entirely. The assumption was simple. No tail means no swimming, means this thing just drifts wherever the current takes it. A passive, brainless blob floating through the ocean by accident. And that assumption was wrong. Embarrassingly wrong. When researchers finally attached satellite trackers to sunfish, what came back broke the model completely. These animals are not drifting. They are working. A sunfish will dive hundreds of meters deep, return to the surface, and then dive again, sometimes doing this cycle multiple times within a single hour. They cover miles of open ocean in a day. They navigate across entire ocean basins with a precision that implies something much more deliberate than accident. But the question that tracking data immediately raised was even more confusing than the original assumption. If it has no tail, what is it using to swim? The answer is the fins on its top and bottom, the dorsal and anal fins. The sunfish swings these in perfect synchronization, not side to side like a shark's tail, but in a flapping motion, almost identical to the way a manta ray or a penguin moves its wings underwater. It's not fast, it is never going to outrun anything, but it is remarkably efficient for long-distance travel through open water. And efficiency, it turns out, is the entire point. Now here's where the sunfish's strategy starts to reveal itself. In biology, body size is not free. Every pound of tissue you maintain costs energy. A great white shark needs to eat fatty, calorie-dense prey regularly or it dies. A blue whale filters millions of tiny shrimp per day just to keep its enormous body running. The bigger you are, the more expensive you are, and the higher quality fuel you need to justify the cost. The sunfish weighs up to 5,000 pounds. It eats jellyfish. This is the part where marine biologists started pulling their hair out because jellyfish are approximately 95% water. Eating a jellyfish is metabolically comparable to eating a glass of water that vaguely remembers being food. There are almost no calories in them. There is almost no nutritional value. They are the rice cakes of the ocean. So how is a 5,000-pound animal powering itself on rice cakes? The answer is volume and monopoly. The sunfish eats jellyfish constantly, essentially non-stop, and it does so in a niche that virtually no other large predator competes in. Almost every serious ocean predator ignores jellyfish entirely because the caloric math doesn't add up for them. But the sunfish built its entire body around making that math work. That frozen, weird, permanently open mouth, it's a vacuum. When the sunfish encounters a jellyfish bloom, it doesn't chew or bite, it creates suction, drawing the jellyfish in and pulling it deep into its throat, where a set of specialized pharyngeal teeth, essentially a biological shredder hidden inside its neck, tear it apart before it reaches the stomach. And because nothing else is competing for jellyfish at this scale, the sunfish has an infinite buffet, almost entirely to itself. The food source most predators dismiss as worthless is the exact resource the sunfish built an empire on. But there's a catch. Jellyfish don't live at the surface. They concentrate in the deep, cold water. And cold water is a problem. The sunfish is cold-blooded. When it dives into water that's a few degrees above freezing, its internal temperature starts dropping. Its metabolism slows, its muscles stiffen. If it stays down too long, its heart will stop. So after every deep hunting session, the sunfish returns to the surface, rolls onto its side, and sunbathes. This is not laziness. This is the entire system working as designed. By presenting its massive flat body, essentially a living solar panel, directly to the sun, it absorbs heat as fast as physically possible. And because it's enormous, once it's warm, it stays warm for a long time. Thermal inertia. The same reason a cast iron pan holds heat after you take it off the stove, while a thin aluminum pan goes cold in seconds. The sunfish's mass is its insulation. It heats up, dives deep, hunts in the freezing dark, burns through its thermal reserve, and then returns to the sun to recharge. Hunt, surface, warm, dive, repeat. It is one of the most elegant metabolic cycles in the ocean, and nobody noticed it for years because from the surface, it just looked like a dumb fish floating around doing nothing.